Okay, so for the next examples in this particular section, we're going to go over what we call the common or parent functions, and these are really important. This is something that you need to memorize. So we're going to go over all 8 of them. We're going to talk about the points that are on there, the domain and the range, and what they actually look like on a graph. So you have all of that information here at your fingertips, so you can use this as a reference guide. So we're going to start off with f of x equals x, which, by the way, this guy is called your linear function. Okay, and we're going to find 3 different points. Typically when we're doing this, we're going to stick to finding 3 points. There's a couple places where we'll only find 2, but kind of consistent with that. What we're also going to do is pretty consistently we're going to use the values -1, 0, and 1 as our x's. There are a couple of spots where we do have to use something different. We'll talk about that when we get there. And these are going to be what we call our critical points that you need, again, have memorized. So if we plug in -1 to our function up here, we would get f of -1 equals -1. So our first point is going to be the point -1, comma -1. So let's write that up here, -1, -1. So if we do the same thing for 0, f at 0 is equal to 0. So this is going to be the point 0, comma 0. Oops, I'm write that here too as well. And then we're going to do f at 1. This is going to be 1. So our third point is going to be the point 1, comma 1. So now we're going to graph these 3 points. So starting off with -1, -1, we're going to go to the left 1 and down 1. That's going to be about right there. We've got 0, 0, which is our origin, and then we're going to go to the right 1 and up 1, and what we end up getting is a nice straight line right through the origin. Okay, so that is our linear function. Our f of x is equal to x. We have our 3 main points, -1, -1, 0, 0, and 1, 1. And then let's talk about the domain and range. So remember, domain are all of your x values this function uses, and as you notice, it's going to continue going out to the left forever. It's going to continue going out to the right forever. So our domain here is all real numbers. So you can use an r, or if you don't like that, you can go from -infinity to +infinity. Okay, the same thing with our range, since it's going to continue going up forever and then also continue going down forever. This is all real numbers as well. Again, or you can use the -infinity to +infinity. Okay, so let's look at our next function. This is f of x equals x squared. This is our quadratic function. Again, let's use our same 3 points. I'm going to make my chart down here. I've got x and y. I'm going to do -1, 0, and 1. So if we plug in f at -1, that is going to be -1 squared. When you square a -1, that is going to give us a +1. So our first point that we find is going to be the point -1, +1. So let's put that here, -1, +1. So if we do f at 0, this is going to be 0 squared. Well, 0 squared is still 0, so that's our second point, 0, comma 0. And our third one, f at 1, that is 1 squared. Well, 1 squared is just 1, so that's our third point, 1, comma 1. So let's graph those 3 points. So this is going to be, we've got our 0, 0 that we found, our 1, +1, +1, and our -1, +1. And what this graph looks like is it's U-shaped. This is the one we were looking at in the previous section. We were finding vertex and x and y intercepts. So same function. We're just going to look at graphing it a little bit different. I know my graph is not that beautiful. I'm not a very good line drawer. So let's talk about the domain. Again, as you notice, as this arrow goes out, it is going to continue going out to the left and right forever and ever. So our domain here is going to be all real numbers. However, our range, which is our y values, are our vertical axes being used. Notice that in this one, it starts here at 0 and goes up forever. So it is not all real numbers because you're not using any of your negative values. So this is going to be a bracket at 0, going to infinity. Okay. So let's look at our next one. This is our cubic function. Okay, so this is our function that is raised to the third power. So again, I'm going to do our chart here, x and y. So we have -1, 0, and 1 again. We're going to plug those into our f of x equals x cubed and see what happens. So f of x equals -1 to the third power. So when you multiply that out, you're doing -1 times -1 times -1. Well, the first two negatives make a positive, but then when you do +1 times one more negative, that takes us right back to being a -1. So our first point here is going to be the point -1, -1. So we do the same thing for f at 0. This is 0 cubed. 0 times itself 3 times is still 0. So our second point is again 0, 0. And f at 1, this is going to be 1 cubed, which is still 1. So this is going to be the point 1, 1. So let's graph those 3 points. So we've got +1, +1, 0, 0, and -1, -1, which honestly are the exact same points we had for our linear function, but our cubic function doesn't exactly look like our linear function. What it's going to do is it's going to start here at the origin, it's going to curve up going to infinity, and it's also going to start here at the origin and curve down going towards -infinity. I like to call this the snake function because it kind of looks like a snake, but anything to help you guys remember what it looks like. So the domain on this one, again, because even though it's going down sharply, it is still slowly going out to the left, slowly going out to the right, so it is all real numbers. The same thing with our range, it's going to go up forever, it's going to go down forever, so it is also all real numbers. So let's look at our fourth common function. That is going to be f of x equal to the square root of x. So this is our square root function. And this is where we're going to have to change up our values just a little bit. I mean, we've talked about the square root in previous videos. One of the things that we can't do is we can't use -1 because there is no square root of -1 right now. So we have to eliminate that one as a possibility. So what we're going to do is we're still going to use 0 because we can take the square root of 0. We're still going to use 1 because we can take the square root of 1. And the next one we're going to use is actually 4. That's our perfect square that we know we can take the square root of. So we're going to do the same thing, starting off with f at 0 this time. We've got the square root of 0, which is going to end up being just 0. So our first point this time is going to be 0, 0. Then we're going to do f at 1. That's the square root of 1. Again, the square root of 1 is just 1. So our second point is going to be the point 1, 1. And then we're going to do the last number here, which is 4. So we're going to f at 4. That's the square root of 4. Remember, the square root of 4 is 2. So our last point is going to be 4, 2. So when we graph that, we've got our origin at 0, 0. We've got +1, +1. And then we have +4, +2. Now when we graph this, remember there's nothing on this left-hand side of this graph. He starts at the origin and he arches out towards the right. I actually kind of think that this particular graph looks a lot like the square root symbol itself. So that's usually how I remember the shape of this graph. I say, oh look, he looks a lot like his actual symbol there. Now as far as the domain, because he stops at 0 and only goes out towards your positive numbers, the domain of this graph is going to be a bracket at 0 out to infinity. The same thing is true for your range because your range does not use any of these negative values. And I know it's a very sharp turn out, but it is raising as it goes. So the domain or the range here would also be from 0 to infinity.